Okay, let's take a look at a few more examples using the chain rule. And the first one was this last example from the previous presentation. There, I just gave you the answer and showed you the solution. Here, I'm going to go step by step. If you happen to already figure this out, you can just fast forward this portion and go on to the next example. So for this example, I regard this as something of the form u to the third. And to find the derivative, it's going to look like 3 times u squared times the derivative inside, which is u prime, or du dx. So I look at this as a general quantity to the third power, and therefore I'm applying basically the generalized power rule for differentiation. The generalized power rule has this last bit of the chain, which is you multiply everything with the derivative of the inside. Now, when you just have an x cubed, the derivative was just 3x squared, right? Because technically, if you multiply everything with the derivative of the inside, it's going to be like dx dx, derivative of the inside with respect to x. So that never shows up, or just 1. But when the inside is more than just x, then the chain rule kicks in. Okay, so let's begin. The derivative is equal to, so we bring the power down, leave the inside the same, and subtract 1 from the power, and multiply everything with the derivative of the inside. Now at this level we need to be careful because the inside is a quotient, and which rule do we need to use? Definitely the quotient rule, right, for differentiation. So with the quotient rule, I write down my bottom term first, or the bottom expression, which consists of 2 terms. So the lower expression times the derivative of the higher, derivative of x minus 1 is 1, minus the higher expression times the derivative of the lower, which is 2, all over the bottom one squared. And I'm done with the calculus. The rest is just simplification. For example, let's see what we have over here. That is 2x plus 3. And then this 2 has to be distributed. But because of the negative sign up front, we might as well distribute negative 2. So negative 2 times x is negative 2x. Negative 2 times negative 1 is positive 2. Do you notice a cancellation? The 2 x's, right? And we're left with just a 5. So now I'm going to rewrite everything. Technically we're done. You can leave it like this, but if you go one extra step, it will look cleaner and it's a more simplified answer. And you may see the answers in that format in the book, so I want you to see how they are getting their answers. For example, 3 times 5 is 15. Then we have x minus 1 squared at the top. At the bottom, this is being squared, and this is being squared. So ultimately we have 2x plus 3 to the power of 4. So that is our final answer for this question. All right, let's take a look at another example. This is number 9. F of x equals cosine square. Same question. What is the derivative of this function? What is f prime of x? So it helps if you begin by writing this function as cosine x quantity squared, because that's exactly what cosine square x is, right? Now, as with all examples in this section, I strongly recommend you pause the video when you feel comfortable, complete the solution, and come back, check us out. Okay? So hopefully you did that, and now here is the solution. This is like u squared, so the derivative is 2 times u to the first, or cosine x to the first, multiplied by the derivative of the inside by the chain rule, right, which is negative sine x. And typically we write this as, just pull the negative outside, negative 2 sine x times cosine x. There's an identity with this, but you don't have to worry about it. But 2 sine x cosine x is a double angle identity for the sine function. If you choose to, you can also leave the answer as such. But again, it's an identity that most people don't remember, so do not worry about it if you did not get that. All right, let's move on to another example using the chain rule. Okay, this one is a really interesting one. G of x equals cosine of the cube root of x squared plus 1. So you don't have one function, you don't have two functions, but you have three functions, one nestled within another in this case. The innermost function is your x squared plus 1. The intermediate one is the cube root of u, let's say. And the outside function is, let's say, cosine of z, the cosine function. Okay, because the outside function is cosine, we're going to begin by differentiating that one. So the derivative of cosine u is negative sine of u times u prime, or du dx. So let's begin by differentiating the outside function, leaving the inside intact. And now we need to multiply everything by the derivative of the inside. And the inside of the cosine function, I'm going to put it as like a 1/3 power instead of cube root, because that will be easier to differentiate. Okay, so in the next step, I write the first portion as it is. And now we just need to be concerned about differentiating the x squared plus 1 to the 1/3 power. Again, if you haven't tried the problem by yourself yet, this may be a good time to pause the video, complete it, and then come back. So this is going to be a simple, like, let's say u to the 1/3 type of an expression. How do we differentiate that? The 1/3 comes down. Everything inside remains the same to 1 less power. And then we multiply everything with the derivative of the inside. So now I'm going to combine my constants. So we have negative 2/3. There's an x in the numerator, also a sine of cube root of x squared plus 1. And what is left in the denominator? Just in the previous line, we had a negative exponent, right? So that is the only thing that we will have in the denominator. That will be brought down as a positive exponent of 2/3. So we're going to have x to the second plus 1 quantity to the power of 2/3. Okay, if you're coming back to check your answer, hopefully you got it. And if not, feel free to post any questions about it in our bulletin board. Let's try another example. Let's see, which one do I want next? Okay, let's try this one, the product rule example. Now, this is not of the form u to a power, let's say 4, because you have this, but you also have that. So for this question, we cannot begin by applying the power rule. So what I see here is a product. So we're going to begin by applying the product rule. So g prime of x equals, with the product rule, so let's call this is our first, this is our second. So I have the first quantity times the derivative of the second quantity. Now at this level, I'm going to need a chain rule, right? When you're differentiating the second quantity here, which is this. So let's apply the chain rule to differentiate that. 4 times quantity x cubed plus 1 to the third, everything multiplied by the derivative of the inside. Plus, that comes from the product rule, right? What do we do now? So now we write the second expression as it is. And we're going to multiply that with the derivative of the first. So we're done with the product rule. We're done with the calculus portion of the problem. The rest is going to be simplification. And to simplify this, let us see what is in common to the first term and to the second term. For example, x cubed plus 1. What is the largest power you can extract from both terms? To the third, right? And also 2x. 2x can be factored out from both of these terms. So I'm going to also try to take out a 2x, and let's see what's left behind. Over the first green braces area, if you factored out what we have factored out so far, what are you left with? So here I'm going to simplify a little bit. So we had there 4x squared times 3x squared. That is 12x to the 4. And here we have taken outside a 2x. So inside we're going to have 6x to the third, right? Because if you multiply these two together, you will end up with 12x to the fourth. From the second part, the 2x has been taken out, x cubed plus 1 to the third has been taken out. So what are we left with? X cubed plus 1 to the first power, right? I don't even need parentheses for that. If I simplify this now, inside the brackets, or you could use another set of parentheses, I have now 7x cubed plus 1. So that's how we're going to leave our answers for that question. So typically we want to try to simplify them as much as possible. And the reason for this simplification is, like in another section, you could be trying to graph a function g of x given with this equation. And sometimes you're trying to find maximums and minimums. There we're going to set it equal to 0 and solve for x. In a situation like that, having it in factored form certainly will be advantageous. All right, another example on the chain rule. Go back this time, if it lets me. Come on, let's see what is going on here. Okay, let's try example number 11. For this example, we're supposed to find the equation of the tangent line to f of x equals sine of 2x at the point x equals to pi over 8. In a sense, this is a very typical question, right? We've done tangent lines many times before, and we always start by finding the slope. How do we find the slope? The derivative, right? So we're going to take the derivative of the function. Okay, what is the derivative of sine of 2x? So you do have an outside function which is sine, and an inside function which is 2x. First differentiate the outside function, leaving the inside the same, and you multiply everything by the derivative of the inside, right, which is 2. And we want to slope at pi over 8, so let's plug in pi over 8 for x. And we can simplify. 2 times pi over 8 is going to be pi over 4. So we need to find now cosine of pi over 4. So hopefully you memorize your trig function values, right? And they come up very often. So in this case, it's going to be root 2 over 2, and it's being multiplied by 2. So we end up with the square root of 2 as the slope. It is the derivative, therefore it is the slope at that point. Okay. Now we need a y-coordinate. To get a y-coordinate, we always go to the original function. So y equals f of pi over 8. So let's plug it in the original function. Sine of 2 times pi over 8. So now we're looking at sine of pi over 4. And that is root 2 over 2 as well, right? At 45 degrees, sine and cosine are equal, so this is also root 2 over 2. So then the point that we're looking at is the x is pi over 8, and the y is root 2 over 2. And the slope that we determined was the square root of 2. So we just have to put the pieces together now. So y minus y1 equals the slope times x minus x of 1. And I know you can simplify this, you can distribute your root 2 and add the root 2 over 2 to both sides. But when numbers are so messy, usually I will allow you to, like when you have pi and so forth, I'll allow you to leave the answer in the point slope form. So if you left it like this, it's fine. Or if you prefer, you can go a step further. And the last question we'll do on the chain rule is this weird looking example. I say weird because we have no equations for f or g or h. We just have a numerical table. Now, how do we interpret the results of this table? Let's just take a look for a minute. Okay, so for example, this value right here tells me that when x is equal to 1, f of x is equal to 2. In other words, that value right there is really telling me that f of 1 is equal to 2. For example, what does this number represent? This is telling me that when x is equal to 1, f prime is equal to 4. So one way to write that would be f prime of 1 is equal to 4. So that's how we're going to read this table. Now the question. They define w of x as follows. It's a composition of two functions, g of h of x. How do we find w prime of 1? Okay. When you have a composition of two functions and you're trying to differentiate, how would you go about doing that? Think about it for a minute. If you said chain rule, you were correct because you have one function nestled within another, right? And the chain rule tells us that to find the derivative of this function, we first need to differentiate the outside function, leaving the inside the same, and then multiply everything with what? You are right, the derivative of the inside, right? But we want to do this, specifically they want to know the derivative at the point 1. So I'm going to plug in x equals 1. That gives me g prime of h of 1 times h prime of 1. And to get the results, I need to check with the table. First of all, what is h of 1? H of 1 is 3, right? So here I'm going to replace this quantity with 3. I have g prime of 3. And what about h prime of 1? H prime of 1 is 5, right? So this needs to be multiplied by 5. But we're not done. We need to know g prime of 3 now. So when x is 3, g prime is equal to 6. So this first quantity will be replaced by 6. That gives us a final answer of 30. I know this question is a little bit weird, but in my opinion, it's a really good question because it truly tests to see if you've understood the chain rule. So you're not relying on an equation, but you need to understand how to apply it even when you don't have an equation. So for instance, could you do this next one? If the w function is defined as g of x cubed, what would be the derivative of w? Please take a moment, pause the video, try it, and then come back. So now my outside function is g, and my inside function is x cubed. So by the chain rule, the derivative equals Differentiate the outside function, leaving the inside the same, and then multiply it by the derivative of the inside. And we want to do this at the point 1. Again, the question was to find w prime of 1. So we're going to evaluate this at x equals to 1. So this means I need g prime of 1 to the third, which is 1, times 3 times 1 squared. So if I know what g prime of 1 is from the chart, then I'm practically done here. And g prime of 1 is 0, right? So I have 0 times 3 times 1. That gives me a final answer of 0. And here is the last one for you. If the function is defined as h of x to the third power, how do you find the derivative of this function? Again, please try it and then come back. So here I have clearly an outside function, and that is a cubing function. So I'm going to rewrite the derivative as 3 times h of x to the second power. And what do I need to multiply this with? The derivative of the inside, of course, right? We want to do all of this at x equals to 1. So I'm going to need to know what is h of 1. H of 1 from the chart is 3. That needs to be squared. And then I need to multiply it with h prime of 1, which happens to be 5. So now we have 3 times 9 times 5. In other words, 3 times 45. And that, I believe, is 135. And that is our last example on the chain rule. Now go find as many examples as you can find and practice it, and you'll do fine.